Analyze in detail the evidence for and against an ancient technological civilization existing in prehistory. For example, around year 10,000 BC. Suppose if true that this civilization was wiped out by a global calamity. Also, analyze the evidence for and against the idea that a civilization such as this could have passed down ancient knowledge to help hunter-gatherers build a new society. Be fair and try to give weight to the evidence as it points to one or the other conclusion. Draw a conclusion and give a % likelihood that either conclusion is true. Below is a balanced, evidence-weighted analysis of the hypothesis that an advanced technological civilization existed in deep prehistory, quote 10,000 BC or earlier, was destroyed by a global calamity, and may have passed down knowledge to later hunter-gatherer or early agricultural societies. I'll separate what would count as strong evidence, what we actually observe, arguments for and against, then give a probabilistic conclusion. Number 1. What the hypothesis actually claims. There are 3 distinct claims, often conflated. 1. Existence claim. A civilization prior to 10,000 BC with social complexity beyond known hunter-gatherers. Cities, writing, metallurgy, machines, etc. 2. Catastrophe claim. This civilization was largely destroyed by a global or near-global event, climate collapse, impact, floods. 3. Transmission claim. Survivors passed down advanced knowledge, astronomy, engineering, agriculture, social organization to post-Ice Age peoples, influencing early civilizations. Each claim has different evidentiary strength, so they should be judged independently. Number 2. What evidence would exist if this were true? If a technological civilization existed, even one destroyed 12,000 plus years ago, we would expect at least some of the following. Strong expected evidence. Mining scars, deep shafts, tailings. Large-scale landscape modification, metallurgical residues, slag, alloys, synthetic materials, glass, ceramics beyond Neolithic tech, persistent chemical anomalies, lead, mercury, isotopes, clear stratigraphic disruption, industrial layer. Moderate expected evidence, dense settlement remains, roads, ports, canals, widespread standardized tools, written symbols or data storage artifacts. Weak but suggestive evidence, unexpected precision stonework, astronomical alignments, cultural myths describing lost ages, sudden jumps in social complexity. Number 3. Evidence for an ancient lost civilization. A. Göbekli Tepe, 9600 to 8000 BC. Why it matters. Monumental stone architecture built by pre-agricultural peoples. Precision carving, coordinated labor, symbolic complexity. Requires long-term planning and social hierarchy. What it shows. Hunter-gatherers were more capable than previously assumed. Social complexity predates agriculture. What it does not show. No metallurgy, no writing, no machines, no urban infrastructure. Weight. Strong for early complexity, weak for advanced tech. B. Sudden climate shock. 12,900 to 11,700 BP Younger Dryas. Facts. Rapid global cooling. Major megafauna extinctions. Sea levels rose to 120 meters over millennia. Coastal settlements from Ice Age now submerged. Interpretations. Could erase coastal cultures. Could disrupt any fragile complex society. Problems. Catastrophic total erasure. Deepland archaeological record remains intact. No industrial residue anywhere. Weight. Strong for disruption, weak for total erasure. C. Mythological convergence. Flood myths. Golden ages. Examples. Sumerian flood myth. Plato's Atlantis. Hindu Yuga cycles. Mesoamerican world ages. Interpretations. Possible memory of post-glacial flooding. Shared human trauma encoded mythologically. Problems. Myths are symbolic, not technical records. Floods happen locally and repeatedly. Myths evolve independently. Weight. Culturally interesting, weak historically. D. Early knowledge. Jumps. Examples often cited. Egyptian stonework precision. Sumerian astronomy. Early calendars and geometry. Mainstream explanation. Incremental development plus lost intermediate evidence. Overestimation of ancient difficulty using modern assumptions. Counterpoint. Some techniques still debated, e.g. granite machining. Weight. Debatable, not decisive. Number 4. Evidence against an ancient technological civilization. A. Absence of industrial signatures. Very strong. This is the single strongest counter-argument. Even after 100,000 years, industrial activity leaves. Heavy metal isotope anomalies. Plastics, ceramics, glass. Synthetic compounds. Distinct soil chemistry. We find none in ice cores, ocean sediments, continental strata. If a civilization used electricity, metallurgy at scale, fossil fuels, nuclear processes, it would be unmistakable. Weight, extremely strong. B. Archaeological continuity. Human technological progression is gradual and traceable. Stone tools, microliths, agriculture, metallurgy. Clear regional variation. No unexplained global reset. If advanced tech existed, we'd expect regressions or anomalies. We see none at scale. Weight. C. Genetic and demographic evidence. No population bottleneck consistent with total global civilization collapse. No genetic markers of isolated elite survivor groups. Cultural transmission patterns align with known migrations. D. Occam's razor. Extra assumptions required by lost civilization theory. Global civilization with no residue. Total erasure except myths. Perfect suppression of material evidence. Selective knowledge survival without tools. Simpler explanation. Humans were smarter earlier than assumed. Social complexity can arise without industry. Coastal evidence is missing, not inland. Weight. Number 5. Could knowledge have been passed down without a civilization? This claim is more plausible than full advanced tech. Plausible transmission. Agricultural practices. Astronomy for calendars. Stone construction techniques. Ritual social organization. Navigation and seasonal knowledge. Implausible transmission. Machines, advanced mathematics, metallurgy without infrastructure, writing systems without continuity. Conclusion here. Open quote, knowledge transfer from complex hunter-gatherer or proto-agricultural cultures is very likely. Knowledge transfer from a lost technological civilization is unlikely. Close quote. Number 6. Probability assessment. Hypothesis A. Advanced technological civilization, 10,000 BC. Estimated likelihood, 5 to 10%. Justification, strong negative material evidence, no industrial signatures, requires multiple extraordinary assumptions. Hypothesis B, socially complex pre-agricultural cultures influencing later societies. Estimated likelihood 70 to 85%. Justification, supported by Göbekli Tepe and similar sites, consistent with archaeology. Explains myths without requiring lost tech. Hypothesis C, small advanced enclave, non-industrial, lost to climate. Estimated likelihood 15 to 25%. Examples, highly skilled stoneworking culture, advanced astronomy, no metallurgy or industry. This is the strongest lost civilization variant, but still not technological in the modern sense. Number 7. Final conclusion. The evidence strongly disfavors a lost technological civilization in deep prehistory. However, it strongly supports the idea that early humans were far more socially, symbolically, and intellectually sophisticated than once believed, and that knowledge transmission across the Ice Age boundary likely occurred. In short, open quote, Atlantis-level technology, very unlikely. Forgotten complexity and lost cultures, very likely. Limited advanced knowledge without industry, plausible but unproven. Close quote. If you want, next we could. Analyze specific claims, Atlantis, pyramids, ancient power tools. Model what a non-industrial advanced civilization could look like. Examine how modern biases distort our interpretation of ancient tech. Compare this to known historical collapses, Bronze Age collapse, Maya, Indus. Just tell me where you want to go next. Just to keep things interesting, why don't you go ahead and model what a non-industrial advanced civilization could look like? Explore as many different potentials as you can think of. Delve into how each different aspect of society could have operated. Then analyze what kind of remnants that civilization would leave behind if it had existed 14,000 years ago. Great prompt. This is exactly the interesting part of the hypothesis space because it pushes right up against what archaeology can and cannot easily see. Below is a systematic modeling exercise. We'll design several plausible forms of a non-industrial but advanced civilization. Explore how each domain of society could function without industry, and then analyze what physical, cultural, and environmental traces would plausibly remain after 14,000 years. I'll stay grounded in known human capabilities, physics, ecology, and archaeology. No hand-waving tech, but also no modern bias. Number 1, defining non-industrial advanced. For this model, advanced does not mean fossil fuels, electricity, mass metallurgy, modern chemistry, large-scale mechanization. Instead, it means high performance in at least some of the following: social organization, knowledge systems, mathematics, / astronomy, architecture and engineering, agriculture or ecological management, navigation and geography, medicine and biology, philosophy, law, and governance, energy optimization using biological or mechanical means. Think maxed out Stone Age, not proto-industrial. Number 2, core constraint, what they could use. Available materials: stone, limestone, granite, basalt, obsidian, wood, bone, antler, plant fibers, cordage, textiles, clay, lime plaster, bitumen, resins, water, wind, muscle power, fire, controlled but not industrial, forbidden materials for plausibility, steel, plastics, aluminum, complex alloys, synthetic chemicals, high-temperature furnaces. Number 3, possible civilization models. I'll outline 6 distinct models, each internally coherent. Model 1, astronomer-priest civilization. Core advantage: mastery of time, seasons, celestial mechanics. Society, knowledge elite, astronomer priests, long-term calendars spanning centuries, agricultural scheduling, ritual cycles. Predictive power equals social authority. Technology, megalithic observatories, stone sighting markers, horizon calendars, mathematical ratios encoded architecturally. Governance, theocratic but data-driven, decisions justified by cosmic order. Economy, seasonal surplus management, trade coordinated across regions via calendars. Warfare, rare, just ritualized, strategic advantage via timing, harvest denial, migrations. # knowledge transmission, oral plus symbolic stone encoding. Geometry embedded in monuments, songs and chants encoding astronomical cycles. Likely remnants 14,000 years later. High survivability, stone circles, aligned monuments, anomalous precision, mythic cosmologies. Low survivability, mathematical knowledge, oral calendars, political structures. Archaeological visibility, Model 2, hydraulics, landscape engineering civilization, core advantage manipulation of water and ecosystems. Society river basin coordination, flood control and irrigation, wetland agriculture, fish weirs and canals. Technology, earthworks, stone-lined channels, seasonal reservoirs, gravity-based water distribution. Economy, stable food production without monoculture, aquaculture plus foraging, resilient to droughts. Governance, managerial technocracy, authority via maintenance expertise. Warfare, control of water equals leverage. Defensive flooding ordinal task knowledge transmission, apprenticeship systems, land-based living manuals. Likely remnants, high survivability, altered river courses, submerged canals, soil composition anomalies, fish weirs often mistaken for natural, low survivability, wooden gates, knowledge of maintenance cycles. Archaeological visibility, often misattributed to later cultures. Model 3, stone precision engineering culture, core advantage, extreme craft specialization without metallurgy. Society master builders, long apprenticeship chains, intergenerational guilds. Technology, hard stone on soft stone techniques, abrasion plus water time, modular stone construction, acoustic engineering. Architecture, earthquake-resistant stone structures, tight tolerances without metal tools. Economy, monumental labor-social cohesion, pilgrimage economy. Governance, builder priests or architect councils. Warfare fortifications, choke points. Likely remnants, high survivability, precision stone blocks, unfinished quarries, tool marks that confuse modern analysts. Low survivability, tools, wood bone, measurement systems. Archaeological visibility, Model 4, knowledge-dense oral civilization. Core advantage, extreme cognitive optimization. Society, memory elites, epic-length oral records, legal scientific geographic data memorized. Technology, mnemonic palaces, chants encoding algorithms, dance and ritual as data storage. Governance, laws remembered, not written, elders as living archives. Economy, trade routes maintained via memory maps. Warfare, strategic deception, knowledge denial rather than destruction. Likely remnants, high survivability, myth structures, repeating narrative patterns across cultures. Low survivability, almost everything physical. Archaeological visibility. Model 5, biosymbiotic civilization, core advantage, advanced ecological engineering. Society, no clear cities, managed forests, grasslands, coastlines, human ecosystem coevolution. Technology, selective breeding, controlled burns, soil microbiome management, multi-species agriculture. Economy, high productivity without fields, extreme resilience. Governance, custodial ethics, long-time horizons, warfare, starvation of enemies via ecological denial, likely remnants high survivability, unexpected plant distributions, genetic domestication signatures, black earth soils, low survivability settlements, tools archaeological, visibility. NAP Model 6, maritime network civilization, highly important, core advantage, oceanic navigation and coastal living, society, decentralized nodes, shared navigational knowledge, seasonal aggregation sites, technology, advanced boats, wood plus fiber, celestial navigation, tidal calendars, economy, fishing, long-distance trade, cultural diffusion, governance, alliance networks, shared mythic law, catastrophic vulnerability, sea level rise wipes out almost everything, likely remnants, high survivability, stone anchors, coastal myths, genetic mixing, low survivability, settlements, now underwater, boats, archaeological visibility. Number 4, what would survive after 14,000 years? Evidence type, survival likelihood. Stone monuments, very high. Earthworks, medium. Organic materials, very low. Metals, none used, nay. Written records, none. Oral traditions, fragmentary. Genetic impact, medium. Environmental markers, medium. This explains why Göbekli Tepe-type sites are exactly what we'd expect, and why absence of industry does not equal absence of sophistication. Number 5. What this model explains well. Sudden appearance of monumental architecture, advanced astronomy without writing, mythic memory of lost ages, knowledge transfer without artifacts, no industrial residue problem. Number 6. What it still cannot explain. Modern-level engineering, advanced mathematics without notation, high population density, global uniformity, precision manufacturing. Number 7. Overall assessment. A non-industrial advanced civilization is plausible, fits known physics and anthropology, would leave ambiguous, easily misinterpreted evidence, would be largely erased by sea level rise. Probability estimate, existence of at least one such civilization, 30 to 40%, global or Atlantis style version, 10%, partial knowledge transmission to later cultures, 50 to 70%. If you want, next we could design a full timeline of rise and collapse for one model. Compare this to specific archaeological sites worldwide. Stress test it against known climate data. Explore how modern archaeology might be systematically missing such civilizations. Just say the word.